two more students will join. But let's start. Write the topic cyclic structure of glucose. Wait a minute, let me okay, everyone. So, am I audible to all of you?
Sir, you're lagging.
I am lagging. Wait a minute. Thank you for telling me. Am I lagging, Nafisa?
No, sir, not at all.
Thank you. Now see, we are going to see what is the cyclic structure of glucose. It's very easy. So first of all, I'm going to write the normal structure of glucose as we know that this is CHO and this is OH, this is H, this is OH and this is OH. Please be focused here because if you will miss it, it is very confusing. And then CH2OH. Now what I'm going to write is the another form of this. Can I write CHO as C double bond O and H? Can I write this?
Yes, sir.
Now, and the rest part is as it is OH, H, OH, OH, and then, oh, wait a minute, and then CH2OH, and then CH2OH, and then H, H, OH, and then H. Now, see, what you need to do is let me know which one is more electronegative. Carbon and oxygen. Oxygen is more electronegative, so there will be negative charge. There will be positive charge because oxygen will attract or withdraw one of the electron from carbon because it is more electronegative. Also, you know that on this carbon, this OH, hydrogen is less electronegative, so it will have positive charge and oxygen will have negative charge. You will not take other OH other than this. Is that clear? Now what happens? Just break this bond. Only O will left and hydrogen will be like this. And again, OH, H, OH. And this will be only O, then H, then H, then OH, and then H. Now see what happens is very easy. This positive will go to this negative. So this will be OH, this will be OH. And this carbon is positive and this oxygen is negative. So what will happen? This will be connected like this. Is that clear, everyone? Please let me know.
Yes, sir.
Very good. So it will be like OH, and I am going to write this like this is C and this OH and this is H. Now my first question is that can you tell me number of chiral carbon here? What will be the number of chiral carbon? Initially, in this normal glucose, the chiral carbon 1, 2, 3, 4. And after the writing the cyclic structure, this will be also chiral because it is sp3 hybridized, and this carbon has this carbon is connected with 4 other different groups. So now it will have 5 chiral carbon. Is that clear?
Yes, sir.
So it's very easy to understand. This is basically Fischer projection. This all are Fischer projection. These are all Fischer projection. And in order to do cyclic structure, we will do like this. Now I am going to, you can see there is a cycle form. Cycle, that means closed ring. So closed ring between this carbon, 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 and then oxygen. Now with the help of this, we are going to write the cyclic structure, which is known as Haworth projection formula. We are going to write it. First of all, you just write it and let me know when you are finished. Then we are going to
Yes, sir. Finish.
finish. Very good. Sneha, Manoj, and Hamza, are you done with this? Okay, Sneha, please do it and let me know when you are done with this. Hamza, are you done with this? Sneha, very good. And Nafis. Now I'm going to write again that cyclic structure so that it will be more easy to understand. C, OH, and then H. Then the rest will be same as it is. There was OH, there was H, there was OH, there was only O, then H, H, OH, and then H, and here it is CH2OH. Now you can see this is connected with this. Now going to number the carbon. It's very important to note. See, all are, first of all are these are, this is chiral, this is also chiral, this is also chiral, this is also chiral, this is also chiral. When we write cyclic structure of glucose, that will have 5 chiral carbon. But when we write the normal glucose like Fischer projection, in Fischer projection, that is that is basically Haworth projection. Okay. Wait a minute. Just wait a minute. Now see, this is basically Fischer projection, and now I'm going to show you the Haworth projection. So Haworth projection formula. So 1, 2, 3, you just did it. Now what you need to do is there is one carbon at this. So I'm going to write a cyclic structure. First carbon, sorry, this is 1, this is 2, this is 3, this is 4, this is 5, and the sixth cyclic atom is O. So I'm going to write a structure like this. This is the first carbon, second, and then this is the second, then this is the third carbon, then this is the fourth carbon, this is the fifth carbon, and this sixth in cyclic structure is O, which is directly connected with the first one. Yes or no? Is that clear to everyone? I'm going to write this one,
Yes, sir.
2, 3, 4, and then 5. Now see, what you need to do is very easy. Whatever is on the left hand side, that will be above. That will be above. Like we got on the first carbon OH and H. So we are going to write this as, wait a minute, like this. Whatever is on the left hand side, that will be written on above, and on the left, sorry, whatever is on the left hand side, that will be written above, and whatever on the right hand side, that will be below. So OH. Now the second carbon has HOH. H will be above, OH will be below. Third carbon, you can see left, on the left hand side OH, that's why I'm going to write OH here, and on the right hand side H, so I'm going to write this H. Fourth carbon, you can see H on the right hand side, above and below OH. Now fourth, wait a minute, fifth. When we go to fifth carbon, you can see fifth carbon has CH2OH and H. This O is in cyclic form. So basically it's very easy. Now whatever is on below will come to CH2OH, and whatever is on the left hand side, it will be H. Is that clear to everyone? Please.
Yes, sir.
Please write it. Please do write it. Whatever is on the left hand side, we have to write. When there will be left and right, left will be on above, right will be on below. But when we come at this point, left and below will be on the top, and left will be on below. So I'm going to write, you can say left, that means top, and right, that means below. Or you can write top, at the place of top you can write above. And when left and below, like this, below will be on top, that means above, and this will be below, that means bottom. Is that clear to everyone?
Yes, sir.
It's very easy. Done, everyone?
Yes, sir.
Now see, its name is basically, this cyclic structure has a name, and its name is alpha D plus glucopyranose. Alpha D glucopyranose. First of all, I would like to tell you about this pyrene. Pyrene has a structure. Pyrene is this. This is a compound that is called pyrene. This is pyrene. Now see what happened here. I just wrote alpha D gluco plus alpha D plus glucopyranose. So basically this gluco, that means it is glucose, and pyranose basically similar to pyrene. That's why it is pyranose, similar to pyrene. Now you also know that plus minus, that plus represent its dextrorotatory. Is that clear to everyone? And this
Yes, sir.
alpha, basically there are two isomers, alpha and beta, same chemical formula, different structural formula. So this will have two isomers. One is called alpha and another is called beta. We will see about beta later. What is this D? See, I have explained D and L, a small d and a small n. D stand for dextrorotatory, L for levorotatory. And what about this D and this L? Capital D, capital L. So capital D means basically the last chiral carbon, on the last chiral carbon, OH on the right side. If OH on the right side on the last chiral carbon, then D, and OH on the left hand side, that means L. So we can write OH on the right side, right on last chiral, then we say B, then D. So it's very easy. Please write it. And it is also like this two isomers alpha. H is on the left hand side. You can see H is on the left hand side. That's why it's alpha. If this H on the right hand side, then it will be beta. And there is another point which is important. Total chiral carbon atoms in cyclic structure of glucose equals to basically 5. Haworth projection. This is called Haworth projection. Is that clear?
Yes, sir.
Can I change the slide? Sneha, Hamza. Okay. Now see, if we have, you can see this carbon has H on the right hand side, OH on the left hand side, and this will be same as it is CH2OH, and that will be connected with one of the oxygen. So what? Wait a minute. Let me write the whole structure because you will get confused. C, H, and then OH, and then H, then OH, then O, H, H, OH, H, and this is CH2OH. Its H is here, you can see, and this will be connected with like this. So you can 1, 2, 3, 4, 5, 6. Please write the cyclic structure.
Yes, sir. Finished.
Finished. So what you did is very easy. So you can see 5, 6 atoms in the ring. The first is basically you are going to write this is first carbon, this is second carbon, third carbon, fourth carbon, fifth carbon, and then oxygen is there. Wait a minute. So it will be like this. And you can see this will be 1, 2, 3, 4, 5. Now, whatever is on the left hand side, it will be on top, above OH, and then H. This will be like OH and then H, and then OH and then H, and then fourth carbon H and then OH, and on the fifth carbon CH2OH and then H. This you can see on H on the right hand side, so it will be beta D plus glucopyranose. So there can be a question, write the structure of alpha D plus glucopyranose. Pyranose is because it's similar to pyrene, that's why it's pyranose. Is this correct, Nafisa?
Yes. Yes, sir.
Very good. Sneha, Hamza,
Yes, sir.
very good. Can I move to the next part?
Yes, sir.
Okay. So there are some points that we need to remember. Alpha and beta are anomers. You will understand what is anomers are called. This is basically C1 anomers. C1 anomers. Basically, C1 anomers, that means the carbon on which it switches. That first carbon, H on the left hand side, H on the right hand side, we just switched and it changes alpha and beta. That's why this is, I'm going to write switching carbon. Okay. So switching atoms or switching carbon, you can say change. So that carbon is called C1 anomers and all. Okay. Is that clear?
Yes, sir.
C1 anomer. Next point is anomers are diastereomer. You have studied it in class 11th also. Diastereomers. Astromers, diastromers, that means basically no mirror image. No mirror image of the compound. Mirror image. If you are going to take mirror image of one and you want alpha will be converted into beta, no, it's not like that. Third is all anomers are diastereomers. Diastereomers. This is very important. Diastereomers. But all diastereomers are not anomers. Are not anomers. Please write. Wait a minute. Oh, let me know when you are done with this. Sorry. Let me know when you are done with this.
Yes, sir. Finish.
Very good. Sneha, are you done with this? Very good. Now see, we are going to learn about the not sucrose, basically this alpha beta glucose fructose. So I'm going to give you cyclic structure of fructose. Cyclic structure of fructose. So see what is cyclic structure of fructose. It's very easy. So first of all, we are going to write the Fischer projection like CH2OH, and then one of the carbon from here will be doubly bonded with oxygen. That represents it is ketonic group is there. And also now there is H, there is OH, and again OH, and again OH, and then H, and then H, and then there will be CH2OH. So this is basically fructose. Fructose. So we did in the same way that we did in glucose. This is more electronegative, doubly bonded negative. This will have positive and it will like this. And again, the last carbon like this, H plus and OH minus. You just need to add the positive to negative, negative to positive. So this carbon, you can see this carbon. First of all, before writing this, please let me know the number of chiral carbon here. Total number of chiral carbon in this Fischer projection. Can anyone tell me?
3.
3. Total chiral carbon in Fischer projection. In Fischer projection. Formula of fructose. Formula of fructose equals to 3. It's very easy, I think. Right? Very good. So this is it. 3 carbon, and you can see which carbon, this carbon, this carbon, and this carbon. Now I'm going to draw the structure. So this carbon, you can see this carbon is connected with O, and O will have this positive H. So it will be OH. It will be, it will be OH like this, OH. And this is connected with this carbon CH2H. So I'm going to write it CH2H. Again, the same, the rest will be same. H, OH, 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 H, H, and then CH2OH. Now tell me the total number of chiral carbon here. Total chiral, oh, wait a minute. This will be connected with this. Total chiral
4.
carbon atom. Very good. In cyclic structure of, this is Haworth projection. We will write, I will write the Haworth projection. In cyclic structure of fructose will be equal to, I think what it will be 4. It's easy, very easy. So please write it and let me know when you are done with this. So this carbon 2, then 3, then 4. Is that clear to everyone? No one is replying
Yes,
except
sir.
Nafisa.
Sir, can you scroll up a little bit?
Yes, yes, why not?
Yes, sir. It's over there.
Okay. Let me know when you're done with this.
Sir, the
Let,
slide changed.
yes, yes, sorry. I just saw it. Please let me know when you're done with this.
Sir, can you scroll down a little bit?
Like this?
Yes, sir.
Okay. Let me know when everyone done with this.
Yes, sir, finished.
Sneha, Hamza. Now see this carbon. You can see I'm going to write the top carbon has. I'm going to write CH2OH on the right hand side and H on the left hand side. Wait a minute, just reverse it. Alpha and beta. We will see C and then OH on the right hand side and this CH2 OH on the left hand side, and the rest will be same as it is H and then OH and then O and then H and then OH, and you know that there will be CH2OH, and again you know that there is a connection between these two. Now I'm going to name it, numbering it first. So the number I'm going to give is very easy. This 1, 2, 3, 4, 5. So 5 carbon in the closed ring and 1 oxygen, total atom 6. So this is oxygen. With oxygen, this is first carbon, this is second carbon, this is first carbon, this is second carbon, this is third carbon, this is fourth carbon, and this 4 carbon in the ring. So basically on the left hand side, whatever, wait a minute, the structure will not be that much good. I have to make some, it should be like this. Wait. Okay, now see, on the left hand side, whatever is present will be above, whatever is present on the left, it will be above, and whatever is present on the right, it will be below. So again, OH, H, and again, H, OH. And the fifth carbon, when we talk about fifth carbon, there is two options, left and above. So whatever on the below, left and below, whatever on the below, it will come to above or top, and then this will be like this. And its name is very easy, you can see. Its name is alpha D minus, that means liver, fructo furanose, because its structure is similar to furan. That's why it is fructofuranose. So furan has a structure similar to this. You can see this is furan. This is furan. Also, you should take care of this CH2H. This is basically, if it is above, that means it is alpha. Above, that means alpha. And if it goes below, that means beta, anomers. Everyone getting my point?
Yes, sir.
Okay. Okay, this is the concept between this. I'm going to write CH2OH and H. When it comes to this, we will go for molecular weight. Whatever molecular weight greater will be on top or above. Are you getting my point? If H is here, it doesn't mean you are going to write it on above or top. Are you getting my point? When
Yes, sir.
left and right failed, then molecular weight preference. We will give preference to molecular weight for above. The one which has more molecular weight will be above, and the one which is less, no, which has lesser molecular weight will be below. Let me know when you are done with this. Then we will see a structure
Yes,
of
sir. Finished.
sucrose, a structure of maltose, a structure of lactose, a structure of starch. Okay, everyone done with this?
Yes, sir.
Completed. Very good, very good. Thank you. Now see, this is done. So I'm going to give you another. If I'm going to switch this CH2OH on this, and you can see I'm going to give OH on the right hand side, and then the rest part is same. H, OH, O, H, H, OH, and then CH2H. And you know this will be, please write Haworth projection. And write the name also. And write the name also.
Sir, then would everything be on opposite sides? Like if in the first structure it's like above, it would be below.
Very good. Just match this with this. So this will be OH and this will be CH2OH, right? Wait a minute. Sorry, everyone. So see, CH2H, and then here it will be OH and then H, and then again you can see this is OH and this is H, and then again CH, and this will be CH2H, right? And you can see the switching position is, see, this was the first carbon, this was the first carbon second. Switching position is second, so it is C2 anomer, C2 anomer, and its name will be beta D minus fructofuranones. Fructofuranones. Is that clear?
Yes, sir.
So everyone did correctly. So this is 1, 2, 3, 4, 5. What about you, Hamza, Sneha? Did you do correctly?
No, sir.
Where you did wrong? No, sir. What was the mistake? I just gave you this. Whatever on the left hand side will be on top. Whatever on the left hand side will be on top. Whatever on the left hand side will be on top. And whatever on the right hand side will be below. Now, when we come to this carbon, you can see hydrogen and CH2OH. So we will go by molecular weight. You can see hydrogen has one molecular weight, and this CH2OH is higher molecular weight than this. So this will be on top and this will be below. I missed one. Okay. It was careless. Oh, there are types of mistakes, right, Sneha? Careless mistake and another type of mistakes. Okay, please write it and let me know, Sneha and Hamza. Then I'm going to write 3 points about this also. Done. Very good. Hamza, you are also done with this?
Yes, sir. I think it.
Okay. Now see, alpha and beta forms are called anomers. Same points. Also, it is called. It is basically C2 anomer because switching position is second carbon. Please tell me in the last point whether it is true or false, whether it is true or false.
First one is false, and the
Very good.
second one is true.
I already have told you very good, very good.
Yes, sir, finish.
Very good. Is everyone done with this? Very good. Thank you. Now see, there is another point which we should know. Meta rotation. Do you know what is this? When this alpha and beta is in equilibrium, that point is called meta rotation. Sorry, not meta, muta rotation. Muta rotation. This is muta rotation. So what is muta rotation? Equilibrium between alpha and beta forms is called muta rotation. Alpha. Please write it and let me know. Then we are going to see the structure of sucrose.
Yes, sir, finish.
Everyone done with this? Okay, thank you. Now we are going to see the structure of sucrose. Structure of sucrose. So sucrose has a chemical formula C12H22O11. This is sucrose, and you know that is it monosaccharide or disaccharide? It is disaccharide. So when alpha D glucose combine with beta D fructose, then sucrose formation takes place. Please see it carefully. I'm going to write the structure of alpha D glucose. So it is like this. And you also know we are gonna H OH. Again, this will be OH, this will be H. Then H OH, and then again OH H. And then we have HCH2OH. This is alpha D glucose, and I'm going to write the structure of beta D glucose. So beta D glucose is also easy. So I'm going to write this is OH, this is H. This is H, this is OH. This is H, this is OH. And then this is H, and this is CH2OH. So what happens here? You just need to remove water from here. You are going to remove water from here. That means this. And there will be, then they will combine. How they will combine? Yeah, I'm going to show. Very easy it is. You can see like this. So there will be H, and then again the rest part will be same H, CH2OH, and then HOH, and then HOH, and then OH, H. And the next part you can see or think of this. So there will be oxygen left only, and there will be bond between these two, and here it will be H, and again this will be no, wait a minute, I did mistake here. This is CH2H, CH2, because you can see CH2H. This is the structure of fructose. I just mistakenly wrote H here, and then HOH, and then HOH, and the rest will be same CH2H. This is known as glycosidic linkage. This is known as glycosidic linkage. Question can be asked like, in sucrose, where is glycosidic linkage present? So you know that in glucose, this is the first carbon. This is the first carbon, and in fructose, this is the second carbon. So glucosidic linkage present between C1 and C2. And you also know that this is monosaccharide, this is monosaccharide, and this is in between mono and mono. Please write it. Let me know when you're done.
Yes, sir, finish.
Very good. Now I'm going to explain about this glycosidic linkage. So you have seen that there is mono part and then O and then mono part. So in between these two, this O is present. That is known as glycosidic linkage. Sorry, glycosidic linkage. And glycosidic linkage present question has been asked many times. Glycosidic linkage is present at C1 and C2. Please write. And then we will go for the structure of maltose.
Yes, sir, finish.
Very good. Are you done with this, Sneha? Now see, we have a structure of maltose. First of all, we will see from where maltose comes. So structure of maltose. So basically, when we mix alpha D glucose and alpha D glucose together, 2 moles of alpha D glucose combined to form maltose. So you already know the structure, so I'm not going to write all the component of this. You can write it on only the required component I'm going to write. You know that this is H, this is H. Again, I'm going to write this. You know that this is O, and this will be like this. And at this carbon, you know that this will be OH, and this is OH. So what you just need to do, just dehydration will take place, and just you need to remove this H2O, and you will get your maltose. Only you have to focus on glycosidic linkers. So there will be H, you can write this, you don't need to show H, or you can show H also, and this is called glycosidic linkage is present at, you know that this is 1, 2, 3, 4, and this is 1, 2, 3, 4. So C1 and C4, glycosidic link is present at C1 and C4. Please write. The rest you can do that, na? Alpha D glucose, you can easily write the whole structure of alpha D glucose.
Yes, sir, finish.
Okay, thank you. Everyone done with this? Very good. Now you can see we will go for the next compound, which is known as lactose. So we are going to see the structure of lactose. The structure of lactose. We just completed maltose. The structure of lactose. Lactose has a chemical formula that is C12H22O11, and it is also disaccharide. It is also disaccharide. Now, how we are gonna make it? So basically, there is beta D galactose combines with beta D glucose. Then we will get lactose. So basically, first of all, I'm going to write the structure of galactose because you don't know at all. So I'm going to write the complete structure of this. Now you can see this galactose. This is OH. This is H. This is OH. This is H. This is H. This is OH. This is H. This is OH. This is HCH2. This is galactose. Combining with beta D glucose. So you know beta D glucose already. So I'm also going to write its whole structure. This is H. This is OH. This is OH. This is H. This is H. This is OH. This is OH. This is H. And also this is H, and this is CH2H. So this is beta D galactose, and this is beta D glucose. So it's very easy to understand. Now what you need to do is just remove water, dehydration. First write it, and then I will explain how we are going to do this. Just remove this water. Please do it. And I will write the product.
Yes, sir, finish.
Very good. Everyone done with this, Sneha? Okay. Please do it and let me know when you're done. Hamza, are you done with this? Very good. Now the product is simple. I'm not going to write all the part, only the important part. You can see this is galactose. You can write the rest part like OH and H2, CH2OH, and this is glucose, beta D glucose. So now see what happens here. There was hydrogen and there was hydrogen. You can write this. There is a linkage of OH between these two. This is called glycosidic linkage. Glycosidic linkage. And glycosidic linkage present at, you know that in glucose this is 1, 2, 3, 4, and this is first for galactose, so C1 and C4. This is very important to learn about the glycosidic linkage.
Yes, sir, finish.
Very good. Sneha, are you done with this? Okay. Now the next structure is the structure of a starch, and it is polysaccharide. So first of all, and it is very important, the structure of a starch. So basically, in a starch, there are two components, and you know that this starch is polysaccharide. Polysaccharide, and it has a general formula C6H10O5, and when whole N, and when hydrolyzed, it gives N mole of C6H12O6. C6H12O6. So basically, first of all, it's important to know that there are two components of this. There are two components in a starch. We have two components. The first one is basically known as amylose, and the second one is known as amylopectin. Amylopectin. So first write it, then we will see what is the difference between this amylose and amylopectin. Then we will move ahead.
Yes, sir, finish.
Sneha, are you done with this? Very good. Now see, difference between amylose and amylopectin. Here it is amylose and here it is amylopectin. So what is amylose? Linear polymer. Polymer everyone knows. Linear polymer of alpha D glucose. That means a lot of alpha D glucose will be there connected. And what is amylopectin? Branched polymer of alpha D glucose. There will be branch. Now the next is only 15 to 20% starch from amylose. And here 80 to 85%, 80 to 85% starch present in this, 80 to 85% starch we can extract from here. Third, it is water soluble, and this point is very important. This differentiation distinguish whatever we are doing. Third, water insoluble. Water insoluble. The next is basically glycosidic linkage here. Glycosidic linkage at C1 and C4. And the fourth is glycosidic linkage at C1 and C4 and branch at C6, carbon 6. Please get all this point, and if you have doubt, let me know.
Yes, sir, Ramesh.
Everyone done with this? Very good. Am I audible? Am I audible?
Yes, sir.
Okay. Now see, we are going to take amylose from, and in amylose, you know that linear polymer of, that means basically several glucose will be connected with each other. Amylose, that means linear polymer of alpha D glucose. Linear polymer of alpha D glucose. So I am going to write, first concentrate here, focus here. It will be like this. Again, polymer, that means several units of this, any unit of this. It will be like this. And you can write all this, you can write the whole structure of alpha D glucose, which is very easy. And there is, you know that OH, H, and then again there is H, and then OH, and again there is OH, and then H, OH, OH, H, again H, OH, H, OH, and again H, OH, and it will go on from this side and from this side also. What you need to do is just remove water from this two, like this H2O, like this H2O, like this H2O, and again you know that from here it will be removed like this, and from here it will be removed like this. Is that clear? Is that clear?
Yes, sir. Yes,
Now
sir.
see what happens is very easy. You can see I'm going to draw the structure again. It will be like this. I'm going to draw the structure, all the structure of above, and again it will be like this, like this. Now you can see if you are going to remove this, there was H left, there was H. So in between these two, this is wrong, H2O. Wait, this is H. So that H2O we are going to do. So what happens? There will be O, glycosidic linkage. There will be glycosidic linkage between these two. Again, there will be glycosidic linkage between these two. Again, there will be glycosidic linkage between these two. And again, there will be glycosidic linkage between these two. And again, there will be glycosidic linkage between these two. And there will be H, 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 and so on. So basically, this is also called alpha links. Alpha link because it is prepared from alpha glucose. That's why it is called alpha link, alpha link, alpha link because prepared or made from alpha glucose. Alpha glucose. Is that clear to everyone?
Yes, sir.
Please write it. Let me know when you are done with this.
Yes, sir. Finish.
Are you done with this, Sneha? Very good. So you can see we need to write a point. Glycosidic linkage here. Glycosidic linkage which is also known as basically alpha links because it is prepared from alpha glucose are present at C1 and C4. Please write it. Then we are going to discuss amylopectin, and in the next class vitamins and all. It will be completed soon. Are you done with this?
Yes, sir.
Thank you. Now see, we are gonna start this amylopectin. So right topic amylopectin. And what it is? It is basically branched. So I'm going to write branched polymer of alpha D glucose and also glycosidic linkage. Here the linkages will be alpha links are present at C1 and C4 and branch at C6. So I'm going to just do this. It's very easy. Please write the above one, then I'm going to write. Are you done with this?
Yes, sir.
Very good. Wait a minute. I just okay. So this is alpha glucose, and we know that there is HOH. And again, I'm going to draw another because it is polymer, and this will have a structure HOHCH2. I just wrote like this because we need to remove water. So this will be the water. And again, there is a branch at carbon 6. And this has a value H, and here it is H. So again, I'm going to do this. So you can see after removing water, what we get here. It's very easy. After removing water, what we get here. O and a structure like this, and this O, and then again CH and O. This is basically branch, and this is carbon number 6. So you can see branch at 6, carbon number 6. So this is our carbon number. Who is the host? Hamza Sekhani, you are the host. Please write it and let me know. Then from here we will discuss in the next class. Are you done with this?
No, sir.
Very good, Sneha. I will see you all in the next class. Thank you.
Thank you, sir.